If we were to look at the end result of the stock simulator, we already have it parted off to finish thickness. We have this chamfer cut, and if you look down in here, we already have everything machined down to where that boss is. So all we need to do is the 632 tapped hole and the interior work, which we can copy from the first side. Okay, so let's do that. We're going to click on lathe up 1. We're going to copy, and then we're going to paste. Okay, and then we need to right click on it, and we need to make sure that we make it default folder, so anything new we do is in there. We're going to change the name to op2, and we can delete the 1 in brackets. Okay, and we're going to go into that setup. We edit it, and it's still a turn op. It's going to be op2 the lathe. We're going to keep a cylindrical stock, but at this point don't have any extra material on any of the sides. Okay, we're continuing from the previous machining job. How much is in the chuck? That depends on how we're holding it. So if we were going to hold it on the outside, it'd be the majority of the part. If we're going to hold it down on the hub, it would be just the hub. For safety, I'm going to go ahead and assume that we have it in the chuck, and so we're going to set that as if actually the majority of the part is in the chuck. We shouldn't be doing any exterior work. Now, from a surface finish standpoint, I'd much prefer to hold this with a collet. It doesn't damage the surface like a chuck does. Won't make marks on that nice machine finish we have on the outside. It's also easier to keep things safe. Assume worst case scenario, we don't have access to a chuck for this. It's really for collision detection is the purpose. So in our model, our overall height of our part is 0.52. So let's put that in, 0.52. Now right now it's facing the wrong direction. Okay, it's backwards in our chuck. And that's because of our origin. Okay, so we're going to scroll down, and it's still going to be model front, but we're going to change the face that we're using for Z, which goes to the opposite side. And the X is still facing in the same direction as our sketch, so that's good. The outline of the chuck is now changed. So we don't need to reverse anything. It should look like this. Make sure it's in the same orientation as your sketch. And then we're going to go back and we're going to change our program name to 1272. It's going to be op2 for the lathe. And then we can accept that. Okay, so there's our new stock. In reality, this material is not really even there anymore, but if you wanted it more accurate, you'd have to model the part at different levels of stock. Okay, so of all the routines we have here, we shouldn't really need a facing operation. So we don't need that operation. Assume we've got our process dialed in enough that we don't need to do that over. Okay, so then we're going to go to the next step, and we've got our turning groove, and that came in and just did a partial groove here. We don't need it. And this is the one for the backside. Okay, so then we got our turning profile. So that was turning profile 1 on our previous operation. So that one came in and did a chamfer. We don't need that one because we can't reach the chamfer with this particular tool. So we're going to have to redo that routine. We could leave it in there, but I think its job is going to be taken up by a completely different tool. So let's go ahead and remove that turning profile. Now this second turning profile is doing the outside, so we don't need that one either. Okay, we've gotten down to our spot drill. We'll need that. We'll need a deep drilling cycle, but we're going to use a different drill bit, so we'll recycle that one, and then we're going to have to add a tap cycle. All right, let's go to the turning profiles. Okay, so we've got our initial groove. We're going to need that. We have a hub on this side. And then we have our next turning profile that machines the balance of the pocket away. We need that. And then we had our single groove that came down and cut this feature here. We no longer need that. And the last one's the parting operation, which we don't need either because we've already done that. Okay, so we got this reduced down to 4 copied routines. We're going to have to add a couple to do chamfers. At least one to do a chamfer, and we're going to need to add a tapping cycle. Other than that, we've got everything ready to go. Okay, well, let's just follow suit and let's just start with what we've got. So we've got our spot drill. We're going to edit the spot drill. And we want to go to a chamfer that's big enough that it accommodates the major diameter of the thread. Okay, so the nominal major diameter of a class 2 632 thread is 138 thousandths. Okay, so we're going to go to Geometry tab. We're not cutting the face that's selected. We're cutting the hole from the other side. We're going to Next tab, and we want to put negative 138 thousandths divided by 2. We're going to subtract 0.01 from that number, making it larger. Negative number, go a little bit deeper. Next tab, or accept the default, and accept. Okay, so we have a chamfer that should be slightly larger than the threaded hole once the thread's established. Okay, we're going to go to deep drilling. We're going to go edit. And we need to switch tools. We need from the lathe library, we need the tap drill for the 632. So if we look at our list, the tap drill for the 632 is the tool number 9, 107, number 36 stub drill. Okay, we're going to select that drill. It should be a little bit bigger than the last one we had. We can leave the feeds and speeds alone. We're going to select our hole, which is the threaded hole. And if you notice it's going shallow, that's because some parameters we have set that we've copied from the previous operation. So in the previous operation, remember, we selected a face as the bottom, and then we said we wanted to go 0.14 deeper. Okay, so we're going to go from hole top, but we're not going to go to the selection we have here. We're going to go to hole bottom, and we don't want to extend 140 thousandths or we'll blow out our 2 millimeter hole at the bottom. So we do want to break through with the tip, but we're going to put 0 under the parameter for breakthrough depth. So the resultant should be pretty much what we modeled at this point. Okay, we're going to the next tab, and we're going to do a Peck depth of half the diameter, so 0.07 divided by 2. So our Peck depth gets a little bit bigger because it's a bigger drill bit. And it's not going to be taking a full diameter off because remember we've already pilot drilled this with a 2 millimeter. So this actually might be a little conservative, but it'll make a little noise, but hopefully it'll be a truer hole the way this works. Okay, we're going to hit accept. Alright, so now we've got our threaded hole going through, or the tap drill for it. Now we want to go ahead and do the tapping. So we're going to go drill. We're going to select from the library. We're going to go to the lathe library, which I keep skipping. The lathe tool library, and we're looking for our tap. That's tool number 10. I never liked 1000 RPM with a tap. They break so easy. It's not worth it. Okay, we're going to select our hole. And we're going to go to the next tab. And we're just going to go to the bottom. We don't want to break through. We should have enough clearance at the bottom of the hole. So the default setting should be fine. I would force it to be right hand tapping. It outputs a different code, but just to be careful, and hit accept. Okay, so there's our threaded hole. Now sequence wise, it doesn't really matter whether we do the drilling before the turning, but you want to put the drills together so they can go in sequence. Typically you put them in the magazine or the turret close to each other so they don't have to move very far on tool change. Again, we need to do a relief groove, which is this first routine, and then we need to do the turning that's going to remove the rest of it. We're going to use the same boring bar, but as you recall, we had to use two different sets of geometry. So currently we have the wrong sketch shown for this profile. Let's left all the way to the left. We're going to go to our model, and we're going to make the lathe profile invisible, and we're going to make our turning profile visible because we need it with a square edge to result in the toolpath we desire. Okay, so we're going to go back to the lathe tools, and the first profile, we're going to edit it, and we should be able to keep most of the parameters the same. So we'll leave the first tab alone. On geometry, we're not selecting this line. We're going to select the one that's on the side of the part that we're working on, but it's good that it highlights which one we're using. So we'll select the opposite side. We're going to need to select containment, and we're going to select the top and bottom of our pocket. We'll go to the next tab, and then we're going to go to our heights, and I think we can leave this all at default, and we should be able to leave all this at default. And on the last tab, we should be able to leave all this at default. So let's hit accept. Yes, we've got a safety warning. We want to go straight in and straight out, and we get our groove. And now this makes it safe for our other cutter to come in, or the same cutter to come in, but to do multiple passes and drag back without hitting material on the back side of the tool. Alright, that was relatively painless. Now let's go to the next one. We're going to edit this tool, or sorry, edit this routine. We're going to leave everything the same on the first tab. We're going to leave it alone. On the next tab, instead of these three profiles, we're going to clear those out. And then we need to switch our sketches. So if you pull down this menu, if you're careful, we can now hide the revolve sketch and display our section view, which is what we need for this one. Okay, now that we've done that, we're going to select the chamfer, this line, and this line. We go to the next tab. All this should be pretty much at default. We can keep the same face selected, but to be safe, let's switch that over to the other side. But when we do that, we have to reset our spacing. So we had that set at 300 thousandths when we had it selected before. Next tab, we're going to leave it default. Last tab, we'll leave it default. We'll hit accept. And now we get our routines that just cut in that zone. We're going to do the last routine for this part, and that's to cut the chamfer on the hub here. Not a real critical feature, but we do want to make sure we don't gouge anything else. So we're going to go to turning, and we're going to do a turning profile. And we're not selecting the default tool that's coming up here. We're going to go to our lathe tool library, and we're going to take tool number 7. Okay, we'll leave everything at default on the feeds and speeds. On the geometry tab, we're going to select model, and we're going to select the single segment. Then on confine, select the larger face, and then we're going to pick the edge of the boss, not the surface, because it'll force it to machine that surface. And we're going to go to our outside tabs, and we're going to go to selection, and our selection is going to be the outside of the hub, convenient diameter, and then we're going to go to selection on the second, and we're going to pick the edge of the top of the smaller diameter of the chamfer. Going into the next tab. Okay, we're going to switch from allowing axial and radial grooving to not allow any grooving. We're not going to do any rough cuts, and we're going to use wear compensation. On our last tab, we want to increase the retract amount to 0.3, which is the significant amount. We want it to pull out so that after it cuts the chamfer, it's not going to retract into our outside diameter. Okay, and we don't want the lead out to be the same. So we want that to be at 90 degrees. And we want it also at 0.3 so that we make sure we clear the part. After that, you should hit accept. And we should get the toolpath that looks like this. So it's cutting the absolute minimum on the diameter. Okay, so I'm going to do the quick simulation. It'll show what the second side of the part looks like. Center drill, coming in with the tap drill. I'll speed this section up on the video. Tap. Of course, we're getting our gouge warnings from this tool that are phantoms. And then we cut our chamfer. Okay, so we should be done with that operation. Now it's time to move on to milling. We've completed our turning operations. We're going to collapse these down because we need to do one milling operation. Now I would suggest that we use this boss here as a locating feature. Everything is turned around it. You could potentially even put a 2mm pin in to locate more accurately. And then we can clamp on either this surface or this surface in a vise with a soft jaw or fixtures that center it. And then we're going to come back and just cut these windows. So it's really only one routine, but the setup for the fixture to build this would actually take longer than cutting the actual part. So there's different ways of approaching this. I'm going to put the origin at the top center, and that would allow us to use a probe or indicator to locate center of this hub off any of these round features, or even the outside diameter of this pocket. And that would allow us to dial it in so that at least these cuts are as close to concentric as we can after switching processes. Another approach would be is to put the origin at the bottom. You would indicate on your fixture instead, then drop your part in. That might be a little more accurate in the sense that you would be locating and indicating in on the side of the part that was turned first, and so that would be concentric to the majority of the features which were made on the first operation. But there's different approaches. So again, let's go with a new job. This one is going to be milling. This will be the S60-127 Op 3 for the mill. Okay, we're not using a relative size box. The stock is actually the part itself, but we're going to be cutting. Yeah, let's just say it's from Solid, and we're going to select the model itself as the stock. All right, so our origin's moved over to a weird place, and we're going to use Z-axis and X-axis origin. So we're going to pick this surface as our Z-axis for up, and it snaps automatically to an origin that's here on the center, so that's good. But our X-axis, it really doesn't matter. If we want it in line with one of the clockings, I guess that would help us. But either way, let's just leave it where it is. Okay, so our X-axis, center of our threaded hole, X and Y. Alright, so because at this point the part is symmetrical as far as its circularity until we cut these holes in it. So now we're going to go to, we've got our stock box point, top center is fine, and our program name, we're going to call that the 127 3, and program comment S60-127 Op 3 for the mill. I don't know why I like the op capitalized. When it outputs in the post processor, everything's going to be capitalized. Okay, so let's accept that. We're going to change the job to reflect the name, S60-127 Op 3 for the mill.